Hello friends, welcome to my YouTube channel. Today we will be solving this problem of removing duplicates from sorted array of Leetcode. Let's jump into the problem statement. So you are given a sorted array. We have to remove the duplicates and return the modified array and the new length. So for example, given this array which has the elements 1, 1, 2, 2, 2, 3, 3, 4, 4 and 5, we have to return this 1, 2, 3, 4, 5 since there are these are the duplicate elements which are 1, this one and this one, this one and this one. After removing this we will be left with this and this and this. So how do we do it? So one simple approach can be by taking an extra space. So we are this is the function's signature. So we have a function which takes a vector of numbers which are of type integers, okay, and we have to basically return the uh, remove the duplicates and return the array, okay. So what is the most trivial case? So the most trivial case is if the size of the vector is less than or equal to 1, in which case we directly return the array without any modification, right? Since only one element cannot have duplicates, or less than one element cannot have duplicates, okay. So how do we do it? By taking extra space. So we know in C++ we have something called as sets, okay, which basically stores any kind of elements uh, without having any duplicate. So if we try to insert duplicate elements, it will only keep the one element and do not keep other elements, okay. So let's say for example we have like 1 1 2 2 2 2, sorry, 2 2 2 3 3 4 4 5, okay. So when we insert 1, the set will have 1. After that when we again try to insert 1, it will not insert and keep only one element. After that when we insert 2, it will insert 2, and then when again we try to insert 2, it will not insert till we get a new element which is 3, then it inserts, and so on and so forth. So this will be the set, okay. So in C++ the set is sorted according to the key. So that means the numbers in the set will be in the sorted order in the set, okay. So now what we do is in this we add the each of the elements in the set by using the insert function, okay. We have created a set with numbers and we insert it, okay. Now what we have to do is simply take all the elements in the set and replace the elements from index 0 to the number of elements in the set, okay. So we iterate over the set and we keep from index 0, we keep replacing the given array with the current element in the set. So let's say the given array had this was the given array. So here we replace 1 with 1, and then we will replace the next we'll have the number 2 which will replace here, so this will become 2. Then again this 3 will go here, it will become 3, this will be 4, and this will be 5, okay. So and we return the size of the set because that is what is asked in the question. Now can we do better than this by without using any extra space? So let's think how to do it. So we have this array which has these elements, okay, which are already sorted. We have to return only the non-duplicate elements. So we can do this by taking two pointers, okay, one a beginning pointer which will be, let's say, here, and one will be the end pointer, which will start from the next element of beginning. Okay, this is the end pointer. Now, as long as the element pointed by the end so equal to the element pointed by beginning, we will keep moving the end pointer forward. Okay, until we get a non similar element. So here we find that 1 is not equal to 2, so we uh, increment the beginning pointer to here, and we copy this element to here, so this becomes 2. Okay, and again we will increment the end pointer, right? Now the beginning is here, which has array has 1 2 and the end is pointing here. So as long as we the beginning pointer is equal to the beginning element pointed by beg is equal to end, we keep moving end forward. Okay, so 2 is equal to 2, we will move end to here. Again we see that 2 is equal to 2, so we will move this to here. So now we have a non duplicate element. Okay, so what we do is uh, we will move the beginning to here, copy this element to here. Okay, this becomes 3 now, and then carry on moving the end pointer to here. Okay, so now beginning is here and end is at this position. So since both these elements are same, we move the end to here. So now these two elements are not equal, so we increment the beginning pointer to this place. Okay, and we copy this element here, so this becomes 4. Okay, and we move the end pointer forward, right? Again 4 is equal to 4, so we move the end pointer here. So since these two are 4 is not equal to 5, we increment the beginning pointer here, we copy this element here, so this becomes 5, and then we move the end pointer forward. Since this is the end of the list, we have finally found the non-duplicate elements. So these are the non-duplicate elements, which is basically 1 2 3 4 5. Please note that we are not changing the size of the array, so that is, we are not erasing these elements in the array. Okay, we are just keeping track of all the non-duplicate elements. So this initial array is modified and we return the size of this, that is 5, which is equal to beginning plus 1. Okay, since array indexing starts from 0, it will be beginning plus 1. Okay, so let's see the code for this. We have the function which takes a vector of numbers. Okay, and uh, we have to return the non-duplicate elements and the length of that. Okay, so the trivial case is same to what I have discussed earlier. So these are the two pointers which beginning points at index 0 and end points at index from beginning plus 1. Okay, starts with beginning and while end end is not equal less than the size, we have to keep going. So if the numbers are equal, we continue, okay, till we don't find a number which is not equal. When we find the number which is not equal, we increment the beginning, we copy the end pointer number to the beginning, and then continue to the next item, okay, and at the end we return the number of items, which is beginning plus 1. So that's it. What is the time complexity for the algorithm? uh, so the time complexity is basically we are running from the start of the array to the end of the array, which has size n, so it is order of n. And what is the space complexity? So the space complexity is basically we are not using any extra array or set or anything, we are just having these two variables, okay, and that's it. So the space complexity is order of 1, right? So that's it for this video. Hope you enjoyed watching this and learned simple but quite not so intuitive problem. If you like the video, do share, subscribe and share this with your friends, and thanks for watching.